everyone, so for this video, we're going to solve the transportation problem. So let's start. So here's our transportation problem. So let us first find the northwest corner method. So we will check first if the total supply is equal to the total of the demand. So we have here 150 plus 250 plus 300. So we got 700. So same as demand. So we have 100 plus 150 plus 300 plus 150. So the total is 700. So this is now a balanced transportation method. So from the upper left corner, move to the lower right corner. This is now our northwest corner. So we have to know the supply and the demand. So the supply is 150 and the demand is 100. So the minimum of 150 and 100 is 100, which is our lesser value. So allocate the 100. So the demand of the first column is already satisfied, so we need to cancel. We need to subtract the supply, the value of supply, to 100. So the remaining value is 50. Next is allocate the 50 from S to D2, which is our second column. Next is subtract the demand 50, then the remaining is 100. Now allocate the 100 into the second row. So as you can see, we already meet the demand of the second column. So same process. So subtract the supply. So the remaining is 150. Next is allocate the 150 into the third column. So same process again, subtract until you meet or satisfy the demand and supply. As you can see, we already met the supply and the demand. So let us now calculate the initial cost of the northwest corner method. So we have 10 times 100 plus 8 times 50 plus 6 times 100 plus 4 times 150 plus 7 times 150 plus 11 times 150. And now we have the initial total cost of northwest corner, which is 5,300. So let's move on to the second method, which is least cost method. And in this method, we need to identify the least cost, which is we have here 2 less cost, 4 and 4. So we have here the least cost 4 and the supply is 300 and 100, so the minimum is 100, which is our lesser value, so we need to allocate the 100. As you can see, we already satisfy the first column of demand, so we need to cancel. Next is we have here 4, allocate the 200, then subtract 200, so the remaining is 100, so subtract this also 200, so the remaining is 50. Next, identify the another least cost, which is 5, so allocate the 100, the remaining 100 of the demand. So as you can see, we already satisfied the third column of demand, so cancel 0, and we are now going to cancel this one since it's already satisfied the third column. So same process, you need to find the least cost. So we have here 6, so this is now 50, so the remaining 50 is allocating into the 6, subtract, the remaining is 100. So as you can see, we already satisfied the first row of supply, so this is now 0. To continue this method, same process as we did in the first place. So as you can see, we already satisfies all the quantity of supply and demand. So let us now calculate the total cost. So we have here 5 times 100 plus 6 times 50 plus 6 times 50 plus 4 times 200 plus 4 times 100 plus 9 times 100 plus 11 times 100. So we have here the initial solution, which is 4,300. We have Vogel's approximation method. We have here a row difference and a column difference. First, we need to identify the least cost. So we have here 5. In able to get the row difference and the column difference, we need to subtract the second least cost and the first least cost. So we have the first row, we have 6 minus 5, 1. In the second row, we have here 6 minus 4, so 2. In the third row, we have 7 minus 4, so we have 3. Let's go to the column difference. So we have here the least cost 4 and the second least cost is 10. So 10 minus 4 is 6. Then second column, we have the least cost 6 and the second least cost is 8. So 8 minus 6, we have 2. In the third column, we have 4 and 5. 5 minus 4, we have 1. And in the fourth column, we have least cost 6 and the second least cost is 8. So 8 minus 6, we have 2. Next is among the difference of row on column, we need to find the largest value. So as you can see, we have the largest value of column difference. So we have 6. To allocate the first column, we need to find the least cost of the first column. So we have 4 here. So the supply is 300 and the demand is 100. So the minimum of 300 and 100, so we have 100, which is the lesser value. See, we need to allocate the 100. So it is already satisfied now the first column. So we need to cancel the entire column. To continue this same process. So we are done now to satisfy all the quantity of supply and demand. So let us move on to the total cost. So we have 6 times 150 plus 4 times 250 plus 4 times 100 plus 9 times 150 plus 7 times 50. So we have the total cost, which is 4,000. Since the total cost of VAM is the lowest, I will use this method to proceed the Moody. To resolve the generosity, we make use of an artificial quantity. The quantity D is assigned to that unoccupied cell which has the minimum transportation cost. The quantity D is assigned to S1D3, which has the minimum transportation cost is equal to 5. The next method is Moody method. So we have this formula Cij is equal to Ui plus Vg. So we can rewrite this formula to get the Ui and Vg. So here's the formula of Ui and Vg. We let U3 is equal to 0. So we have V1 using the formula. Our Cij is 4. Then minus U3, which is 0. So 4 minus 0 is equal to 4. Then we have V2. So our Cij is 9. Then our U3 is 0. 9 minus 0 is equal to 9. So we have also V3. So our V3, our Cig is 7. Then our Ui, which is U3, is 0. So 7 minus 0 is 7. So we have U1. So we have U1. So our Cij is 5. And our V3, since we already had V3, which is 7, so we put 7. 5 minus 7 is equal to negative 2. So we have V4. So our Cig for V4, we have 6 here. 6 minus u1. So we already had new one, which is negative 2. So we put negative 2. So 6 minus negative 2 is equal to 8. We have u2. So our CIG for u2 is 4. Here, 4. So our VG, which is V3. So we already V3 here, 7. So we put 7. So 4 minus 7 is equal to negative 3. So we put all the value for U1. So U1 we have negative 2. U2 we have negative 3. Our U3 we have 0 because we let U3 is equal to 0. So our V1, we have V1, 4. So we put 4 here. And our V2, 9. So V3, 7. And our V4 is 8. Next, we have step 2. Find Dij, all unoccupied cells, where our formula is Dij is equal to Cij minus Ui plus Vg. So we have the first one. Our Cij is 10 here, 10. Then our U1 plus V1. So here in our table, based in our table, we have our U1 is negative 2 and V1 is 4. So 10 minus negative 2 plus 4 is equal to 8. So we have here 8. So the next one is C12 minus U1 plus V2. So we have here 8. And then negative 2 for our U1 and 9 for our V2. So we have the result 1. And then next is C21 minus U2 plus V1. So our Cij, C21 is 11. So we have here 11. So our U2, negative 3. Our V1, 4 here. So we have 10. So C22, our Cig is C22. So 6, we have 6 here. And then our U2, negative 3, V2, negative 9. So we have 0. So our C24, which is Cij, 8. So we have here 8. Our U2, negative 3, V4, 8. So the result is 3. So the last one is C34 minus U3 plus B4. So 11. Here, 11 minus our U3. So in the step 1, we let U3 is equal to 0. So we have 0. Our B4, so we have 8. The result is 3. As you can see the result here, since there are no negatives, therefore there is not possible to reduce the total cost. So we have the result. The result is already here and based on our Vogel's approximation method. So we have 0, 0, 0, 150, then 0, 0, 250, 0. Then we have 100, 150, and 50, and 0. So we have S minimum is equal to 4,000, which is our total cost in Vogel's approximation method. So we cannot proceed to the looping since there are no negatives in the result of step 2, which is find the DIG of all the unoccupied cells. That's it for this video. I hope you find this video helpful, and see you in the next one.